Today's video will explain the design of the standard template library's Deque through the UML class diagram. Hello, I'm James Helfrich. Many containers in the standard template library have very complex UML class diagrams. The Deque, fortunately, is not one of those. However, it does have some very unique design features which we'll discuss today. Now, the standard template library does not specify exactly how the Deque is to be implemented. However, it does introduce some performance constraints. One of which is once you drop an element into the Deque, it must not move, no matter how you reallocate or push and pop. And the second is we must be able to access individual elements as well as push and pop at O sub 1. And this implies an array of arrays implementation. Now, this means we're going to have an array of pointers, and each pointer is going to refer to a block, which is an array of individual elements. Now, let's take a look at the class diagram to see how we're going to implement this. First of all, we're going to start with a Deque, of course. And all containers have the same basic things: a default constructor, a copy constructor, a destructor, and an assignment operator. We also have a size, empty, and clear, and we expect these from pretty much every container. We're going to have a front, back, and square bracket operator. Now note that the square bracket operator is unique to the C++ standard template library. Most implementations of the Deque do not have the square bracket operator. They just have front and back. In other words, most implementations use a Deque as a double-ended queue, and we don't have access to the middle of a queue, just the ends of it. However, the standard template library introduces the square bracket operator, which must be O sub 1, and that introduces a great deal of complexity. Now notice how the front, back, and square bracket operator all return a T, which means the Deque must be a template class. Next, we're going to have push front, push back, pop front, and pop back, as you'd expect from every implementation of the Deque. We're also going to have an iterator, which means we must have an iterator class, which is a nested class. Now, how are we going to implement this iterator? Well, because it's very difficult to know exactly where in the block we are and how many blocks there are, we can't just have a pointer into the Deque like we do virtually every other iterator. In other words, the vast majority of all the iterators in the standard template library are simply pointers to the underlying data structure, but the Deque cannot, because the iterator must be aware of the block structure. Therefore, the simplest implementation is to have a Deque index as well as a pointer to Deque. And therefore, when we dereference with the iterator, we're actually going to call the square bracket operator. Now, notice how the iterator does reference a Deque, and therefore it's going to point back to it. All right, now that we have the begin and end, now we can start thinking about how we're going to implement the Deque. Now observe, we're going to have a collection of T's, and the UML class diagram specifies all collections the same way. We don't actually specify here that this is an array of array implementation. We're going to have a number of elements, of course, so we could do size and empty very efficiently. But we're also going to have an IA front, and an IA front is going to be the offset of the Deque index to the array index, and where IA corresponds to the array index. Now we can learn more about the different indices schemes in another video. We're also going to need to know the number of blocks we currently have, as well as the number of cells per block. Now, a trick here is we need to be able to translate a Deque index, which is what the client sees, into an array index. And this is as if all the different blocks were back to back to back to back lined out in memory. But of course, that array is going to correspond to a collection of blocks, and each block is going to have cells in it. Therefore, I'm going to have to be able to reallocate, add more blocks. I need to be able to access individual block and cell from a Deque index. So I'm going to have private methods called IA, or array index from ID, which is Deque index, as well as block index from Deque index and cell index from Deque index. Now we can learn more about the underlying design of the Deque in the Deque chapter of the C++ data structures textbook.